Have you ever thought about seeing two sunsets in a single day? It sounds like something out of science fiction, right? But it's actually possible. If you're at the top of the world's tallest building, you can literally watch the sun dip below the horizon, then you just hop in an elevator, shoot up 160 floors, and you get to watch it set all over again. It's wild. And that's what we're diving into today, the absolute mind-bending limits of scale right here on our planet.
So here's our game plan. We're going to start by looking up at the tallest structures we've ever built. Then we'll go in the complete opposite direction, plunging into the deepest holes we've ever managed to dig. After that, we'll check out nature's own giants, the highest peaks on Earth. From there, it's all about the most massive machines we've ever created. And finally, we'll uncover the largest living things on the entire planet. It's going to be quite the journey.
All right, first up, reaching for the sky. For centuries, humanity has had this obsession with building higher and higher, creating these incredible structures that just scrape the clouds. This race to the top has given us some of the most impressive feats of engineering in all of human history. But, the truth about where that race stands today, well, it might just surprise you.
Okay, get this. For nearly 4,000 years, the Great Pyramid of Giza was the tallest thing we had ever built, period. Then, of course, the Eiffel Tower came along. But honestly, both of them are just dwarfed by today's champion, the Burj Khalifa in Dubai. We're talking 828 meters. You could stack the pyramid and the Eiffel Tower on top of each other, and you still wouldn't reach the tip. And this thing wasn't just built, it was the result of this global race to the sky, this fierce competition between cities and nations, all wanting the prestige that comes with having the world's tallest building. It's a massive symbol of economic power.
But here's a little secret these megatowers are hiding. A huge chunk of their height? It's completely unusable. I'm serious. For the Burj Khalifa, the top 244 meters, that's nearly a third of the whole building, is just an empty spire. They actually call it vanity height, and it exists for one simple reason: to claim the record. See, there's enormous marketing value in holding a world title. So developers just add this relatively cheap, unoccupied spire, and boom, the building's official height and its global profile just skyrocket. It's basically the architectural equivalent of wearing platform shoes. If you only count the usable floors, the Burj Khalifa is way closer to its rivals than you'd think.
So does that mean we've hit our physical limit? Oh, not even close. Back in the 90s, during Japan's crazy economic boom, a time of just insane architectural ambition, engineers designed something called the Exceed 4000. This thing was a theoretical 4-kilometer-high vertical city. It could house over 1 million people and even had its own internal high-speed maglev train system. The design proved that, yeah, structurally, it's possible, but it was never built. The economic boom ended, and the price tag was, a staggering $1 trillion.
So what's really stopping us from building even higher? Well, it's not just physics, it's economics. Once you get above the 63rd floor, the cost for each new floor starts to grow exponentially, because more and more of the building's space has to be dedicated to just holding the whole thing up. And then you've got the physical challenges. The pressure on the materials at the base is immense, so you need new, stronger stuff. The building has to be designed to constantly sway with the wind using these giant counterweights. And then there's a really simple problem: elevator cables. Traditional steel cables just get too long and heavy. For a 1-kilometer tall building, the cable's own weight would be too much for it to even lift. Okay, so we've reached for the sky. What about going in the other direction? Humans have always been fascinated by what's right beneath our feet. It's a frontier that's just as mysterious as outer space. So, just how far down have we actually managed to go?
Our journey downward starts with a hand-dug well in the UK that's actually deeper than the Eiffel Tower is tall. Pretty wild. Nature, of course, goes even deeper. There's a cave in Slovenia with a single vertical drop of over 600 meters. But the deepest natural point on Earth, that's the Mariana Trench. It's an abyss so deep you could drop Mount Everest in there and you'd still have 2,000 meters of water above it. But the deepest point humans have ever reached, it's not a mine. It was a scientific drilling project in Russia that started during the Cold War. It's called the Kola Super Deep Borehole, and it reached a mind-boggling 12,262 meters. It took them 20 years just to see how deep they could go.
But here's the part that really messes with your head. Despite that incredible depth, the Kola borehole only got about 0.2% of the way to the Earth's core. We have barely, and I mean barely, scratched the surface of our own planet. To put that in perspective, if the Earth were an apple, we wouldn't have even broken through the skin. It just shows you how vast the unexplored parts of our own world really are.
So why can't we just keep digging? Well, the deeper you go, the hotter it gets, and the more intense the pressure becomes. At the bottom of that Kola borehole, the temperature was a scorching 180 degrees Celsius. That's hot enough to make the metal on the drill bit as soft as plastic.
The rock itself started to act more like a liquid under all that pressure. Our current technology, our hardest alloys, our most advanced materials, they just can't handle it. It's like trying to drill a hole through a blast furnace.
So, we've looked at the limits of human engineering, but what about the giants of the natural world? We all think we know what the tallest mountain on Earth is, but the answer? Well, it's a lot more complicated and honestly, way more interesting than you might think.
So let's just ask it straight up. Is Mount Everest the tallest mountain in the world? The answer you learned in school is yes, but the real answer is, it kind of depends on how you measure it.
You see, there are actually 3 different ways to measure a mountain. Mount Everest is the highest point above sea level, and that's the standard way we all think about it. But if you measure from the base of the mountain to its peak, the tallest is actually Mauna Kea in Hawaii. It's a huge, dormant volcano that rises over 10,000 meters from the deep ocean floor. And then, if you're looking for the point on Earth that's physically the farthest away from the planet's center, that would be Mount Chimborazo in Ecuador.
How on earth is that possible? It's all because of something called the centrifugal effect. As the Earth spins on its axis, it actually bulges out at the equator. Kind of like a spinning basketball gets a little bit wider in the middle. This shape is called an oblate spheroid, and since Mount Chimborazo is located right near the equator, where that bulge is biggest, it gets an extra boost. Its summit is the farthest point from the Earth's core, and technically, the closest point on the surface to the stars.
All right, from natural giants, let's turn to the absolute mechanical titans of human ingenuity. Driven by our need to mine for resources and explore the universe, we have built machines on a scale that honestly rivals nature, with the power to literally reshape the world around us.
So I want you to meet the Bagger 293. It's this monstrous bucket wheel excavator they use in German coal mines. At 225 meters long and 96 meters high, it is one of the largest and heaviest land vehicles ever built. Now, it's not fast. It moves at less than 1 kilometer per hour, but it wasn't built for speed. It was built for power. It can move 240,000 cubic meters of earth in a single day. And here's the truly insane fact. To power this one machine, you need as much electricity as a small city of 20,000 people. That just shows you the sheer scale of our energy needs.
But even the Bagger 293 has rivals. For a long time, this supertanker, called the Seawise Giant, at 458 meters long, was the largest machine ever built. But today, that title goes to the Large Hadron Collider. It's a massive particle accelerator with a circumference of nearly 27 kilometers, buried deep under the border of France and Switzerland. This incredible machine, built by thousands of scientists from over 100 countries, was designed to answer the most fundamental questions about our universe by smashing tiny particles together at nearly the speed of light. Its scale isn't just a testament to engineering, it's a testament to human curiosity.
We've seen the limits of steel and stone, but what about the limits of life itself? Let's explore the biological giants of our world and the fundamental law that basically governs just how big they can possibly get.
The key to understanding all of this is something called the square cube law, a principle that Galileo first described. So imagine a cube. If you double its size, its surface area, the outside, quadruples, but its volume, all the stuff inside, increases by 8 times. The same exact principle applies to living things. As an animal gets bigger, its weight, which is tied to its volume, increases much, much faster than its strength, which is related to the area of its bones and muscles. This is why an ant can lift many times its own weight. But if you magically scale that ant up to the size of an elephant, its legs would just instantly snap under its own massive weight.
The square cube law explains why we don't see land animals the size of buildings roaming around today. But in the past, giants really did walk the earth. The Argentinosaurus, a dinosaur that weighed up to 100 tons, was probably the largest land animal ever. So why could they exist back then but not now? Well, one theory is that the atmosphere was different, with higher oxygen levels. That would have fueled more abundant plant life and more efficient metabolisms, allowing for bigger bodies. But for a lot of these giants, their size eventually became their biggest weakness. When the climate changed, they just couldn't find enough food to support their enormous frames, and they went extinct.
So who are the reigning champions of size today? Well, the blue whale is the most massive animal on Earth, weighing in at nearly 200 tons. It can only get that big because the buoyancy of water helps support its immense weight, kind of cheating the square cube law. The tallest living thing is a redwood tree named Hyperion, standing at a towering 116 meters. That's near the theoretical limit for how high a tree can even pull water up from its roots. But the largest single organism on Earth is something you would never, ever expect. It's a fungus in Oregon.
Nicknamed the humongous fungus, its body is this vast underground network of tendrils that covers over 9 square kilometers, making it the undisputed king of scale in the biological world.
You know, after this journey through the world of giants, you're kind of left with this humbling thought. All those impossibly tall towers and colossal creatures from our stories and myths, they would all likely collapse under their own weight in the real world. Our imagination can dream of infinite scale, but reality? Well, it's bound by the elegant and very strict laws of physics.
It might seem a little frustrating that these limits exist, but these constraints, gravity, the square cube law, the strength of materials, they're not just barriers. They are the rules of the game. They're what force life and engineering to get so incredibly creative, shaping the unbelievable diversity of forms we see all around us, from the smallest insect to the largest whale. Each one is a perfect solution to the challenges of its own scale. There's a real beauty in.
So, we've explored the physical limits of our world, but that human drive to push boundaries, it's relentless. So I guess the question to leave you with is this. What is the next great barrier, whether it's physical, technological, or intellectual, that humanity is going to challenge? What's next on the list?